So my name's Tyler. I work at PagerDuty, and like Matthias said, I help organize this meetup a little bit. And I've given a couple talks for this meetup, and they're pretty much all the same. It's just I was just working and I learned something, and I wanted to talk, or I wanted to learn more about it, and then talk about what I learned. So in this case, it is metaprogramming. So I think I've been working on Elixir for about 3 years now, and I type my code, I make my Phoenix routes, I make my database queries, and I kind of just, I know what to do for the most part. But then lately I started to want to dig deeper a little bit, and metaprogramming seemed like the advanced thing to do. So I started to read into it, and I got a book that's really good. Oh, shoot, I had it here. It's called Metaprogramming and Elixir, and it's written by the guy who made Phoenix, the Phoenix framework. And the Phoenix framework is a lot of metaprogramming. It's so he knows what he's talking about. It's a really good book and it's short. So anyway, what is metaprogramming? So metaprogramming is code which writes code. And here we have an example, some example code that you guys are probably familiar with. It's just an example of an ecto repo, but there's actually a lot of metaprogramming going on here. Use is a macro. We'll talk about more about macros mean. Def and if, those are macros as well. Guard clauses, that's metaprogramming, etc. So it's kind of all around you. So if you've been using Elixir, you've probably been using some things that are generated for you by metaprogramming and using macros and stuff. And if you wanted to know the things you're using, if they're macros or not, this is something that I think was added in a documentation recently, or at least I didn't notice it up until recently. And it's that, oh, let me switch to the point, is that you can tell which functions are macros and which are not. So this is just the kernel module, Elixir kernel module. And so raise, it's denoted that it's a macro by this macro word here. And then as a counterexample, put in is not a macro, so no macro. So we can prove this to ourselves, like that something is or isn't a macro. And first we're gonna look at put in. So I'll talk more about quote in a second, but the important thing is that we're using this quote thing, which is going to give us an alternate representation of an Elixir expression. And in this case, our Elixir expression is just, we're calling put in, we have an empty map, we want to put in key in val into key. And when the result of that is this alternate representation, I'll call it for now, of our expression. And then if we take the output of that, this is an IAX. You can, if anyone didn't know, you can get the output of this, like number 3 expression, by just saying v3. And so I'm taking basically this and piping it into here. So what I'm doing there is just I'm expanding some macros. And this isn't important for now. The important thing to notice here is that the output here is exactly the same as output here. Because metaprogramming at Elixir happens at compile time, we can invoke it manually using it to expand it like this. And since the outputs are the same, it means that there was no macros to expand. So this is not a macro or any kind of metaprogramming going on here. But then we said that raise, that was a macro. So if we do the same thing and we quote raise, you can see that the output here is completely different than the output out here. And again, I actually don't even know what a lot of this stuff means. I didn't dig that deep. But the important part is that it's different because macro expansion occurred. So now let's talk more about quote, that quote. What is quote? So quote takes an expression or multiple expressions and returns you the AST, which is the abstract syntax tree. And I don't want to dwell on this too long because if you just Google like metaprogramming and Elixir, like everyone's talking about the AST and this and that, AST, blah, blah, blah. But for our purposes, it's just kind of important to note that it's just a representation of our code that's going to be transformed a couple more times and eventually end up as something that the virtual machine will run and use. So here I just have some simple math expression, 1 plus 2 times 3 minus 4. And if you quote that, you get the AST here. Down here is the same thing, but I just removed some of the noise to make it a little bit easier to see. It looks like Elixir's ASTs are represented in like a prefix notation, which is to say that it's always the function first, followed by the arguments. So as we know, math, to evaluate this expression, first you have to evaluate the 1 plus 2 and then 3 minus 4. And you can kind of see that here in this tree structure. We have the plus function, which has its arguments 1 and 2, the minus, which is 3 and 4, and then the multiplication takes its arguments from the results of those. So that's a brief word about quotes and ASTs. We can look at a slightly more interesting AST. Oops, I wasn't supposed to click that yet. So I mentioned on the first slide that macros are all around us and that if is actually a macro. So when we look at this AST here, we kind of expect, we see if, we have our condition, so this is just another function in Elixir. So its arguments are the variable a and the value 10, and then we're going to either return big or small. If I take that AST and expand it, here we get something different. So, macro expansion's happening. This is a macro, but it's not that hard to understand. So we expand it. We see that the if has become a case. And if you went and looked at the source code for Elixir, you would see that, in fact, if is a macro that's implemented with a case statement, but everything else is the same. Our expression just ends up over here in this AST. We're still looking at the value a, the value 10, and then the return values are the same as well, just in this slightly longer, because it's expanded, case statement. So all this is to say that metaprogramming is just altering the AST. Again, I don't want to dwell too much on what the AST is. The important part is just we're putting in code that wasn't there before, and that's what metaprogramming is. I guess you could also metaprogram to delete things, but that seems kind of cruel. I'm not sure if any libraries actually do that. So here is a macro. We talked about macros a little bit already. And this macro is not a very good macro, mind you, but it's the XOR operator implemented as a macro. We already talked about ASTs, and we said macros were part of metaprogramming. And if it's part of metaprogramming, that means it's modifying the AST. And in fact, all macros have to return an AST. So here, to achieve that, we just call quote. We saw that returns an AST. And then we just do some things. And those are going to get put into whoever calls this macro. To call this macro, first we have to require it. In your Elixir code, you probably see things like alias my module, or import this module, or use that module. So require is the most similar to alias, where alias brings in all functions, require brings in all the macros. So to call our XOR, we have to first require it, and then we can call it down here like this, give it a truthy operand, and then we can get our XOR printed out. Yeah, if you didn't require it, you actually get a really helpful compiler error. I'm sure everyone's seen this when they tried to do something and forgot to require or alias something, but it even says exactly what you have to do. It says you must require logic macros, so that's pretty helpful. But if you didn't want to require, you can also import. So import will grab all the macros and all the regular functions, and then of course you don't need to prefix it with the module name. So that's another way to get your macros in. Here's another example of a macro. This one is even less useful than the previous one, but the important thing to note here is that the code is kind of divided into two parts. Again, we need to return an AST, so the return value of this macro needs to be a quoted expression. So quote, 9 times out of 10, you're going to see quote, although there are other ways to make an AST. You could make one by hand, in fact, because an AST is a valid Elixir data structure. But the thing here is that we have some code here, foo equals bar. Since this is not quoted, it's not in the quote block, this is not going to get injected or expanded at compile time. This is never going to end up in the code that is calling this macro, whereas these things will. In macro terminology, everything inside this quote block, that's known as the caller's context, because this code is almost literally being copied out of here and pasted to wherever else this fictitious macro is being called. From the caller's context, you don't have access to the macro context, that would be everything outside, unless you explicitly ask for it. So if I want to access foo, or in this case, we're accessing this argument, which is passed in here in the macro context, use unquote. And that's what you can do to grab a reference. Well, some fancy compilation stuff happens, but basically how you can get a reference to that argument. So here, again, we're just assigning some string to a name and we're doing some math. So if we use quote again to examine what happens this time, we have just 1 plus 2, just some regular Elixir code, and then we have our macro. So if we don't worry about this too much for now, but basically we're expanding this again, and we can see that here we have plus 1, 2. So of course that's our non-macro code. And then we have this other code that didn't exist here before, but is coming from this fictitious macro. Oh, 1 plus 2, right, I say that. So if we look back at what that macro was, we can kind of see where everything comes from. So we had our assignment statement, name equals Tyler, that's down here. Name is the variable name. This counter is like some sort of reference to variables, something like that. Not sure exactly, but you can see the value, Tyler. And then, oh, my Zoom camera's in the way, put that down there. And then we have it's like, how does the argument 5 get handed through? Well, we called it here. It ends up in the argument, which we get from the unquote, and then that ends up down here. So we have 5 and 10 as our arguments to plus, and that's that expression right there. So hopefully I'm just trying, the goal of all this was to understand macros better and to kind of just give some concrete examples and to distill what is actually happening by looking at examples. Oh yeah, and a 10. There you go, cool. So I've working in Elixir 3 years, and I think I didn't know anything about macros. We do some cool like OTP stuff, at least I think it's cool. But I've never actually found a use for a macro except for one single time. This is the only macro I've ever written. And what this macro does, we don't need to dig into it too much. This is just to highlight that you don't need to write macros that often. But what this macro does is it's called assert invalid. And I use this in my test to assert that various ecto change sets are invalid. I basically had a bunch of unit tests. They had a lot of boilerplate, and I wanted to make sure that I was giving back good error messages or what have you. I actually wrote a blog post about this a while ago, but it's easier to scroll this code than sometimes to add it all. Oh, shoot, but it's not loading because GitHub is down and all these things come from GitHub. That's too bad. Okay, well, there was supposed to be code samples here. This is like a footnote on a block of code that's supposed to be here that's not loading now. Maybe we'll circle back to that later. Full screen. Cool. So, right, so we just talked about macros a little bit, and hopefully I'm not moving too fast, but one thing I think that I confused about a lot, and I probably already messed it up a couple times in this talk, is that macros are just a subset of metaprogramming. They're not equal. There's lots of metaprogramming that isn't macros, but oftentimes people seem to use them interchangeably, including myself. So that's what's called out with this slide right here. This is the subset operator. I had to look it up. I didn't know it off the top of my head. Oh yeah, hopefully this link works too. Shoot, I was really relying on GitHub. Okay, luckily this works. Cool. So these are some examples. This is like a GitHub repo I'm working on that's private right now, but this is supposed to just be like lots and lots of examples of metaprogramming, kind of like a cookbook. So that if you ever need to do something, you can just look it up here without having to relearn everything there is to know about macros. And I just wanted to highlight kind of two examples that I think are pretty cool. One is that you can dynamically define a function. So here we're doing some metaprogramming. There's no quotes, but there is an unquote. So what's happening here? I have this list of numbers in my module, and I'm looping over each of these numbers and then running this code right here. So since this code isn't in a function, it's just defined in my module, this will happen at compile time, which is the same with all macros. And what's happening here, this is called a unquote fragment. And what we can do there is we can dynamically define a function name. And you can do this, I think there's another way to do this in Elixir, but anyway, function names have to be atoms. So we're gonna loop over this, grab the number 1, make a function out of it. And then its return value, we're gonna unquote that as well, so that we can access that value. So in this case, I'm making a couple functions here, 1 and 2. And when I test them, they just return the values 1 and 2. Pretty simple, but cool. This is a powerful thing. And this is just a simple example of it. A slightly more concrete example of this, let me make this bigger actually, so everyone can see. A slightly more concrete example of this is something that I've seen in libraries, and I think the Elixir source code does this too with like some Unicode stuff, is that you can, instead of looping over just some list that I defined, you can actually load some assets and make them into functions at compile time. So what I'm doing here is I'll call translations, and it translates from English to French in this case. And I'm reading the file in, I'm just printing it out for the purposes of the demo. And then I'm just kind of looping over each line, which is like comma delimited line, and doing something similar, except I'm not defining the function name dynamically. This time I'm defining its argument dynamically. So what I'm doing is I'm making a bunch of pattern matching functions. When I run this code, this is what the file looked like. So it was just 0, 0, 1, English and French. And then when I run my test code, I called 0, 1, and 10, and I got 0, and then this error was raised here because I also defined kind of a catch-all function to what would happen if I tried to pass in something that didn't pattern match on any of the previous functions. And while I was doing this and seeing code like this, my main goal was I just want to see the code that is generated. How can I take this module and see what happened with compilation? So that was kind of like that was the goal I set out to achieve that led to making this talk. And I kind of got there, as we'll see kind of in the end. But if you're wondering what it looks like, we're going to get there. So other than macros, which you use, like I said, all the time with like if statements and def blocks and all that kind of thing, the next most common thing you see is use. So what is use? You're probably familiar with it if you use Phoenix or Ecto. We looked at an Ecto example. You say, you make your module called repo, you say use, you pass some config stuff, and suddenly you have functions that exist and you can use in your repo. Similarly, with Phoenix, you say use, and then you kind of have this cool DSL that lets you define controller routes, lets you define controller routes with a kind of this cool Phoenix DSL. So how does that work? This is taken straight from the Elixir docs. This is their little toy example of what use does. So use, like these 3 characters right here, is actually a macro, unsurprisingly. So if you expand use, which we kind of saw examples of doing macro expansion, what actually gets replaced is a require statement, which, as we know, will grab you all macros from whatever module. So in this case, use X unit case becomes require X unit case. And then it also injects this other line where we take this module X unit case and call this __ using function, and we pass in all of the options that were given this keyword list here. And all that does is call, there's no magic going on here. We look for a function called using, and then we call that function. I said it's not a function, it's a macro. And since it's a macro, that's why we had to have the require. So this doesn't do anything magic. It just does what I said it just did. But what the main power of use is that it provides a convention that now everyone adheres to. If there was no use, then every library you wanted, for example, Phoenix and Ecto, they would probably have to have some line in their documentation that would say, to get using this library, require our specific module, and then pass it these things. And then maybe Phoenix would call it require, main module. Ecto would call it something different. The purposes of use is that we now have a convention so that library authors can just write these using functions, and all of us that use these libraries and consume them are comfortable and familiar with what this use block does. So here is a more interesting and fleshed out example of use, because I was unsatisfied with this one. And this builds on my example earlier of dynamically defining functions. So this is something that I kind of whipped up. So what I wanted to do was I wanted to have a module called translations that would give me English to other language translations in code if I needed it. So starting with over here on the right, this is just an example of using that module the same way you would use Ecto Repo or use Phoenix routes. So I wanted to give my users the ability to specify some languages, some of which might be built into my module. And if they want to also bring their own translations, they could add this parameter on that just tells me where to go look for certain files so I can do my translations. So how does this work? Let's dive through it again. So again, when we say use translations, we know that's just calling using. Then in using, I'm just grabbing my options, which again, languages, additional directories just come from right over here. The next thing I'm doing is I'm looping over this list of languages. I'm dynamically making atoms, which are going to be the function names, which we kind of saw earlier. And then I'm calling this other module I made, loader.load. So this is an example of, this is an imaginary example, I should say. This code isn't used anywhere or anything, but it does run. But this is an imaginary example of a good way to structure your macros. You want to have as little code as possible inside your macro, and you want to delegate everything else out as much as possible. So none of this loading logic, which pretty much just reads a file and loops over it and splits some CSV stuff, none of that needs to be injected anywhere. That can just be called. There's nothing that the caller's context, which is to say over here, there's no information we need over here other than these things that we're passing in, of course, that are going to help us parse a CSV file. So all of this can just be put in this helper module. Anyway, in this helper module, I'm getting some built-in translations. So in this fictitious example, my translations module ships with French and Korean. But since I also gave the ability to add additional languages, this user is bringing their own language called Elixir, and they're giving me the path to it over here. And then I'm looping over each of these, and I'm quoting, which is making ASTs for each, which is generating all these functions over here for us to use. So another point on what to put in your macro, you want the quote block to be as small as possible. Like only the minimum that actually needs to be injected should be injected. And for us, that's just a bunch of functions. We didn't need none of this looping. Like we don't need any of these variables to be present over here. We just want the functions we can call at the end of the day. So if we see this in action, I have this test module I made that just kind of prints out each of the translations. So we can call that, and we get all the translations which are loaded from CSV. And then additionally, there was some other functions I wasn't exercising in that module, but they are now attached to my module because they've been inserted by the macro using use at compile time. So that's pretty cool. That's use in a nutshell. So like I mentioned earlier, my goal though is not just to make toy examples, but is usually to debug some real code I have. So maybe I'm trying to debug, I don't know, some ecto code or something, and I really want to see, I know that I'm using macros all over the place. I'm debugging some problem. I really want to see what code the virtual machine is running. I know what code I typed in, but I know I also typed in use and some macros. Like what is that expanding to? How can I see that? So here's just a simple example of a module because the other one was a little bit bigger. And we talked earlier that if is a macro. So basically what I want to do at the end of the day is see this module expanded such that this if becomes a case. That's all I want to see. So how the Elixir compiler kind of works, based on my knowledge, is it goes in and reads all your files and compiles them. And this is kind of how it works. Like this is a bit of a toy example, but this code works. This code module exists for these reasons. So what we're doing is we're reading this file in, and then we're calling this string to quoted function. And that takes any string that represents Elixir code. In this case, we're just reading it straight from an Elixir file. And then we're quoting it, which is going to give us that AST. And this is that here. So this is not expanded. This is just the literal AST here. So we still have, we can see we have our def statement. We define my function. We have the if, we have the expression, and we have the return results. So that makes sense. But now we want to take this a step further, and I want to see the case statement. That's my end of the day goal. So if we do the same thing, but add on this macro expand to do our macro expansion and see what that gives us, we get something completely different, which is not surprising because we know there are macros at play here, but it doesn't make any sense. We saw just a moment ago that we had my function, like there was def my func, we saw a greater than 10, we saw big and small, and none of that is here. And this stumped me, and I wondered what the heck am I looking at? Like, have we done something wrong? Like, what is all this stuff? And I never actually answered that question. I don't know what all this stuff means or how it's used. I went to Elixir Lang Slack channel, and I talked to one of the Elixir core team guys. His name's Michael. I'm not sure that, I think that's how you pronounce it. He works for WhatsApp in London, I think, or something like that on the Erlang stuff. And I said, hey guys, all I want to do is see my compiled, expanded module. How do I do that? And he pretty much told me that it wasn't worth it, that I was going to have a bad time trying because the Elixir compilation process is stateful. And that my AST that I'm trying to see is never actually really created, or there's never really a reference to it. It kind of just, maybe it exists for a moment in time, but even not really. Which means that all of this stuff, I guess, is to do with like stateful things that the Elixir compiler is doing. But he did kind of help me out a little bit. He said he made this module or this library on GitHub, and then it kind of helps. So I said, thanks, I'll go check that out. And to understand what his module does, we need to talk a little bit about beam files. And you probably have seen them. This is just me doing some code. This is like working on some of the sample code for this talk. And you have your deps down here somewhere else. There would be like, down there somewhere else would be like the lib folder. But even running locally, every time you're compiling your code for tests or to run it locally, you're gonna have these beam files output. So in this case, I was in dev mode. So every time I just did mix compile without specifying the mix environment, I think it defaults to dev, and it generates these beam files. We can see here's that my module one I did earlier, along with some other things. I didn't explore what all of them really meant, but we see the translations module I made, the translations loader module I made. Here, these are all the beam files. And when I kind of look at them in my editor knows something's up. It's not really human readable. I don't think it's really meant to be human readable. And when I clicked this "Do you want to open it anyway" button, it didn't really reveal much. So those beam files exist, and we'll talk a little bit more about them in a second. So if I take this my module and I use his library, which is called decompile, there are some steps to just to like download it and have it globally available as one of your mix commands. You say mix decompile, you give the name of your module, so my module here, and then you say to, and I just say expanded because I'm interested in the expanded definition. And when I run that, I get this, which is really sweet. It's actually even better than what I wanted because I was hoping for the expanded Elixir AST, but here what I have is actually fully expanded Elixir code. And mind you, it's a little bit funny Elixir code, but it is still completely valid. So I can see that if has been replaced with case, as I expected. The statement we're looking at is the greater than operator, which comes from Erlang. Its arguments are still a and 10, and everything here is the same. So this is great. This is exactly what I wanted to see. So how did his library achieve that? When we were basically following the steps the mix compiler or the Elixir compiler was using, we couldn't get that information. Yet somehow this guy was able to get it. And is it because he's an insider on the Elixir core team that he does things that we can't do? And no, that's obviously not true. So how it works is going back to those beam files, there's all of these Elixir, this is Erlang module called beamlib, which I never heard about before. And it's for working with beam files. So you can specify a path. So this is just the one to my module. And beam files are loaded into chunks. So we can grab various chunks from this beam file. And in this case, we're interested in the debug info chunk. I actually found, while I was like learning all this stuff, I found a YouTube video from like Elixir conference like a couple of years ago when Elixir 1.5 just came out. And that's when debug info was added to these beam files. So the problem that it solves is basically before this was added, a lot of the Elixir debugging tools and compilation errors and stuff weren't very good because they were kind of having the same problem that I was having, is that I wanted to see the AST. So if you ever run into like a Phoenix error or something, and it can point you straight to the line number and even what your line of code is that's erroring, that comes from here. That comes from this debug info. So what this debug info is specifically Elixir values, and it's pretty much the Elixir AST of whatever module you're pointing it at. It's not organized in quite the same way, but at least it has what I care about. So it has the definitions of all my functions. If you recall, my function was called myfunc, and it was an if statement that just compared some variable a to being greater than 10. So we can say the same thing here, which is case greater than, or a greater than 10. So what that guy's library did to generate this was he pretty much invoked this thing exactly, and then he just had some extra steps after that to kind of format it back into a nice way. So that's how that magic worked. Oh, I was supposed to click those. So looping kind of all the way back finally, if we go back to my translations, or my module, which used translations, if I use his tool to see what the corresponding module is, this is what we get over here on the right. So pretty much the left is before the Elixir compiler happens, and the right is after the Elixir compiler happens. So you can see that this use stuff is completely gone, and it's been replaced with what it actually does, which is injecting a bunch of dynamically defined functions into my module. So in summary, metaprogramming is modifying the AST. Quote is helpful for returning ASTs, and you have to use it a lot in your macros. Macros are just one form of metaprogramming, and they're kind of useful for the inline stuff, like the if statements and my XOR clause and stuff like that. But if you want to, you can still add other stuff to your modules, and the use keyword doesn't do any magic. It's just a good convention for injecting stuff into people's modules. There's a lot more about metaprogramming. This is pretty much just what I learned in the last couple of weeks, distilled into a talk. But I know there's some other things out there that I also didn't talk about. One of the big subjects is when not to use a macro. I think I've heard it thrown around a lot. Like the first rule of writing macros is to not write macros. A good example of that was the XOR clause I introduced earlier. That could easily be implemented as a function. It actually had no need to be a macro. I wasn't doing anything in the caller's context that I couldn't have done with an anonymous function. But that was just a toy example. But anyway, when not to use a macro is an important subject because it does make your code really hard to debug and read. Macro hygiene is something I didn't talk about at all. The TLDR there is that if you define something in your macro, that variable doesn't suddenly become available in the caller's context. You can't override variables in the caller's context, at least by accident. You can do it on purpose. And I actually did that in my assert, in my change set macro. I didn't cover how macro testing actually, I mean, macros or functions, I guess you just call them. I don't really know. And I kind of was pretty hand wavy about how the Elixir compiler works. I haven't dug too deeply into that yet. I just kind of learned the bare minimum for this talk. Yeah, so that's everything.